Welcome students. Today we are going to study the topic photoisomerization. We are studying types of photochemical reactions and today we'll be discussing photoisomerization reaction. Olefins usually undergo cis-trans isomerization upon irradiation with ultraviolet light. Conversion of cis-alkene to trans-alkene or vice versa cannot be done by thermal activation. It has to be done by photochemical activation. The bond rotational activation barrier is typically 40 to 60 kilocalories per mole for the rotation of the double bond in an olefin. Therefore, thermal energy is not available at room temperature to cross over the barrier for the cis-trans isomerization process to take place. Therefore, olefins usually undergo cis-trans isomerization upon irradiation with UV light. The transformation can be effected by direct irradiation of the olefins or by irradiation in the presence of a sensitizer, and it may either take place through a singlet or a triplet excited species. It is, however, known that isomerization in the triplet state possesses a lower barrier to rotation around the carbon-carbon bond. Triplets are frequently involved because simple olefins absorb light at about 200 nm, and experimentally it is more convenient to sensitize these reactions by using a triplet donor which usually absorbs at longer wavelengths. Now let us study the photoisomerization of the still beans. Cis-trans isomerization by direct irradiation. Trans-stilbene can be photochemically isomerized to the cis-stilbene. In fact, the trans-stilbene to cis-stilbene photoisomerization will attain an equilibrium and will eventually attain a photostationary state. Photostationary state is when the two systems like cis and trans are in equilibrium with the continuous photolysis, certain constant proportion of the cis and trans isomer is obtained. At the photostationary state, there is a conversion from the cis to the trans and trans to the cis in equal amount, equal rates of the reaction, for example, and thereby it reaches a steady state population called the photostationary state. From the UV visible spectra, we can distinguish cis-stilbene and trans-stilbene very easily. Direct irradiation of solutions of either cis or trans-stilbene yields a constant mixture consisting of 93% cis-stilbene and 7% trans-stilbene. So here is the equation showing this. Cis-stilbene or trans-stilbene on irradiation produces 7% trans-stilbene and 93% cis-stilbene. Initial absorption of light by either of these isomers is rapidly followed by intersystem crossing to the respective triplet states. Photoisomerization then occurs via interconversion or probably via a common triplet intermediate. So cis-stilbene or trans-stilbene on absorption of light gets converted into singlet state of cis-stilbene or trans-stilbene. This singlet state undergoes intersystem crossing and triplet state of cis-stilbene and trans-stilbene is formed. Now this triplet intermediate give rise to 93% cis-stilbene and 7% trans-stilbene. Now let us see the cis-trans isomerization by the use of photosensitizer. Benzophenone is a photosensitizer. Photoisomerization of stilbene can be sensitized by an excited triplet molecule having more triplet energy than cis and trans stilbene. Energy transfer from T1 of the donor, that is benzophenone, to either stilbene generates the corresponding stilbene triplet state, which either interconverts to the triplet of the other isomer or goes to a common triplet intermediate. And in either case, final decay to the ground state isomer occurs. Thus, the benzophenone sensitized process can be understood in the following steps. Benzophenone is in ground state on absorption of light. Singlet excited state of benzophenone is formed. It undergoes intersystem crossing (ISC) to form triplet excited state of benzophenone. Now this triplet excited of benzophenone transfers energy to the cis-stilbene or trans-stilbene, and the stilbene is converted into triplet state and benzophenone comes to ground state. Now this stilbene triplet state forms cis-stilbene 93% and trans-stilbene 7%. Sometimes photochemical cis-trans isomerization may take place in the presence of halogen. In this reaction, there is a photochemical production of halogen atoms which add to the olefin, yielding a radical. Elimination of the halogen atom from this radical yields a constant ratio of the cis and trans isomers. So here are the equations. Bromine molecule on absorption of light gives bromine free radicals. Now this bromine free radical add to the olefin, yielding a radical. Now elimination of the bromine free radical from this radical yields a constant ratio of the cis and trans isomer. So today we studied photoisomerization of stilbene in detail. Thank you so much.